Hi, Albert, how are you? Hear me?
Yeah.
Yeah. So please go to the school, download the simulated test 7. Why last time you actually just call some sorting? You forget how to do sorting? And calling a function from a library is not going to get any point, okay? You probably get 1 point, 2 point, but that's not the way you should answer. Yeah, in AP they like you to work on your own work, not something like that. Okay, is that okay?
Yeah.
don't try it. Okay, don't. Unless that you really cannot remember anything. So today, please download this Sim 7 like last time. Okay, and you can submit 2 files in the same location. Hi, Selena, how are you?
I'm good. How are you?
Okay, I'm okay. Hello, how are you?
Hi, I'm good.
Yeah, please download this one. What's that? Simulated test 7. And when you upload, you can upload 2 files. Okay, single test you can upload 2 files. So you just copy upload 2 files, or you put into the inline editor. One inline editor that actually is fine. Okay. Okay, this week every day I'll give you a test session. Okay, so even tomorrow and Thursday. No, we have 1 more day only, right? Tomorrow is the last day. Yeah, sorry. Let's see, we have 1 more minute. Okay. Jessica is not coming because Jessica tomorrow she has a AP Physics 1, so I don't think she will join. But Karina maybe. So let's wait. Hello, hi Karina, how are you?
Hi, I'm good.
Please download this simulated test 7. Okay.
Okay.
And we are going to get started soon. Okay. And prepare your editor and everything. A couple of things I would like to say. Number one is, please, in a paper, top left corner, you put your AP ID and your initial, say EC, okay? And then in your answer, please put your A, B, C like this, part A, part B, part C like this. Okay, some of you actually include the whole thing. You actually give us whatever import, whatever. I don't think that they are interested in those statements, and they have to figure out where is your code. Okay, so that actually does not help you. Well, if you submit that, I'm not sure whether it will be deducted point or not. Maybe not. Okay, maybe not. And I don't think they will deduct point from you, but well, they will have to spend time to figure out where it is. Okay, is that okay? So try to submit only the part that you consider to be your solution. Okay, but on the top left corner, please put your name. I'm sorry, your initial and your ID. Okay, AP ID first and then initial. Okay, everybody ready? I set up 25 minutes. Work on the part 2 first. Okay, part 2 is a long problem. Okay, we have Selena ready, Albert ready, 2 ready. Okay, Amber ready. Okay, everybody ready, okay? So now I'm going to count down. 5, 4, 3, 2, 1, start. Okay. Okay, please upload at least one version, and then you can continue to work on it if you like. Okay, I give you 5 more minutes to work on it. So please upload at least one version, and then when before about 2 minutes left, you upload another version if you need to have a new version, right? And we only when there is only 1 minute left, you must submit all. Okay, but you are allowed to make multiple upload. So you upload one version first, wrap up upload one version first, and you can continue to check. And then about 2 minutes, you have to get your final version ready. Okay. And then after that, be prepared. The second problem will start once the 5 minutes expire.
Dr. Cho,
Yes?
I can't, I think there's like something wrong with, either my computer or the website, because I can't get onto the page.
Me too.
You can't go to the page?
Yeah.
Let me see. Okay. My website is the same. I'm using the website right now, actually. Let me see. Okay, let me stop the stopwatch. Okay, so as soon that we do, wait 1 moment. Okay, don't worry. So I reset the clock. Okay, don't worry. Let's have another 5 minutes to start. Okay, and then let me see. Let me share my screen. You said that my website cannot be accessed or what? Or cannot be uploaded?
Site
I can't
can't be
access
reached.
the website.
The website cannot be reached?
Yeah.
Weird. 1 moment, okay? Don't panic. So let me share my screen now, okay? Did you see my screen?
Yeah.
Yep.
Yeah, let me actually close whatever I have, okay? And then let me try again. So here I have a Moodle eco24.com, okay? Well, the site cannot be reached. I see, let me see. How about my eco24.com? My site cannot be reached. It's so strange. Okay, send to my email. Is that okay? Send to my email. I will handle it. So it is sent to my ECHOU510 at gmail.com. 510 is a zip code, okay? Gmail.com. Okay. I'm not sure. Look like even my own website is not accessible right now. I'm still using it a moment ago. Actually, I'm doing grading for some of your homework a moment ago. Wait. I'm not sure because this website is my website is hosted on Bluehost. I'll check. Maybe Bluehost has some big problem. Let me check Bluehost. Okay, send to email, and then we would work on Bluehost is healthy. Okay, let me see. Okay, send to my email, and then how comes that my website cannot be accessed? I'm not sure. Server, well, a moment, try again. Okay, so you see, I tried to log into my Bluehost account, but I actually got kicked out as well. Okay, so I think it's a problem with Bluehost, not me. Is that okay? So since you guys have already downloaded the problem, please, let's just upload it. I'll give you another, let me reset it. Reset to 3 minutes. Is that okay? Send email. And then after that, we work on second problem. You guys all have the second problem PDF, right? Let me actually send it, actually. Actually, it's the same problem, same PDF. But anyway, let me send one more time, okay? Let's bypass this problem, okay? So, yeah, don't worry. Yeah, I'll start. Please send email, okay? We have 3 minutes to come down. So here, let me actually send the simulated exam 7 to you, okay? Okay, so I'm sorry, let's send to Selena. Sorry, I should send to everybody. Okay, please download from the Facebook. I think maybe Amber need the email, so let me actually send to the email side as well. Okay. So here, let me send to.
Oh, Dr. Cho, I got the Facebook thingy.
Yeah, so I mean, you got the Facebook already? This one? Oh, okay.
Yeah.
Can you download this one?
Yeah.
Yeah, okay. If you had that one, then I don't need to send by email. Anyway, please continue, okay? Don't get bothered. Yeah, if you have something like this, you have to, you can let me know, okay? In the real exam, what will happen? I think probably you just try, but when you get problem, you use a screen capture to capture it, and then you need to document the error, and then you need to request for a gene makeup test. Is that okay? If it happens in the exam, you cannot upload. Then you document what's wrong with it, and then you request for a gene makeup test. Everybody has a second try. Is that okay? Don't panic. Don't panic and but to download the simulated exam 7, we are going to start with question 2. Actually, a small question. That's part 1, okay? The part 2 is longer. Part 1 is shorter. When I compile these, I actually don't know 25 minutes first or 15 minutes first. I'm assuming the small one go first. And this year is the only year we have this kind of problem. Next year may go back to the 3-hour exam. And it's unfair to have such kind of problem. Yeah, we are going to next one, okay? Okay. So now let's go 15 minutes for small problem. Okay, go. Hello. Yeah, please upload, okay? And the website now is working. Please try it out for me, okay? Hear me? Yeah.
Yep.
Please upload to the website. I talked with. I actually talked with the technician, and we actually chat over here, and I think it's their server problem. Okay, the website that I put on this Bluehost server, and it's their own server problem. Okay, we did not do anything wrong, and it's their own server problem. Okay, but it is fixed now. Please try it out. Okay, try it out if actually it works or not. Should be able to submit now. But in the real exam, don't panic. Okay, no matter what happens, don't panic. The worst case is just you document down whatever happened and then ask for a makeup test. And then you need to take the test again in June, okay? Okay, after you upload your things, then come back at 9:05, okay? Come back at 9:05 after you submit your solution, okay? You should take a break and then come back at 9:05, okay? Selena, are you there?
Yep.
You received my grading for simulated test 6, right?
Yes, I believe.
How about also the mock test 4?
Yes.
Yeah, both of them, right? Okay, okay, good. I just make sure. Okay, Albert, you are 2, right?
Yeah.
Yeah. Okay, make sure. And then Amber, you still have a mock test 4. I haven't finished grading yet. Okay. And Corina, I still see your email, but I haven't downloaded it yet. Okay. So please, when you finish uploading, you can have a break until 9:05. Okay. I'm back 9:05. Okay. Hi, Selena, are you back?
Yep.
How about Albert?
Yeah.
Yeah. How about Karina? How about Amber?
Yeah.
Okay. Since you are all back, okay. So we'll start to look at the problem. The first one is the so-called moving average. Okay. What is moving average? Moving average is when you have the stock price every day is like this, right? So if we use a 3-day window to look at it, it should have some sort of average for the trading window, right? 3-day average. So the data won't be a swap of that one. It actually will be something like this, right? So sometimes moving average represent the trending better than the data itself. Is that okay? Hello, is that okay? Yep. Okay, so that's what we are looking at here. So consider grade averaging scheme in which final average of student score is computed in different from the traditional average if the score have improved. Score have improved if each score is greater than or equal to the previous score. So you have a increasing window, then we say it actually is improved. So 50, 53, 80, that is improved, okay? 50, 50, 20, that's drop, so it's not improved. So 50, 80, that actually improved, okay? So we have, okay, return true if the successive value in the score is greater than equal to the previous value. That score has improved. And then we also have a average window that I talked about it already. That's a moving average. And then the last one, find more average. If the value in the score have improved, return the average of the element in score which index greater than or equal to the score with the index greater than or equal to the score then divide by 2. Otherwise, return the average of all of the values in score. So it said that you calculate the average of all values, or the value in the score have improved. Return the average of the elements in score with index greater than or equal to scores that then divide by 2. So it actually is the second half. So has improved. Okay, so here this one actually say that second half improve. Okay, so here we have 4 divided by 2, so you have a 2, so it's starting from 2. This one 5 divided by 2, you get 2, so it is this 3. Okay, is that okay so far? So this one is not hard. A actually is finding the average of a window. B is checking the average of in a window has improved or not. C is actually checking whether it has improvement or not. If it has improvement, then we only check the second half. If not, we actually find the average. But the second half defined as the n divided by 2 or greater. Okay, so that's not hard. So let's get started with this one. This one is called student record. Okay, so we have data private integer array and then scores. Okay, and then we need to do first one private double average integer first and integer last. Okay, so 2 indexes are given to us, and it actually has a precondition of what? First less than less and within the correct index range. So we don't need to worry about the index out of bound problem. Okay, we don't need to worry about that. So let's do this one. Integer sum equals, let's do double. Okay, let's do double, because double actually we will return for average right away. So actually integer sum equals 0, and for integer I equals first, and then I less than equals last, I increase, and then your sum plus equals scores i's value at the end, return this one sum divided by your last minus first plus 1, right? So you have 3 to 5. So it's 5 minus 3 plus 2 plus 1. That's totally 3 number. Is that okay?
Yep.
Yeah, so this one is the average. Second one, we try have improved. Okay, have improved is said that have improved is actually what? Return true is successful value in score is greater than or equal to the previous value. So you have to check every individual value, okay? Okay, so here let's see. has improved is going over to the whole array. So you have a private Boolean, okay, has improved, okay. And then we do this one. This one is you need to check all the two value windows. So integer I equals 0, I less than scores the length minus 1, I increase, right? Is that okay? We check every two number window, and if actually scores I plus 1 actually is greater, has improved, so it's greater equals, right? Greater than or equal to, equal is okay, right? 50-50 is okay. So scores I, this one is greater than, so actually if it is less than, that is not actually improved, right? In this case, we return false. Is that okay? We
Yep.
check the condition for greater, but I changed to not greater, less than, and it actually is not improved, okay? Otherwise, we check everything and it's improved, okay? Now, the last one we have public double, okay? Final average, okay? And in this case, if has improved, okay, then we return average of one of scores length divided by 2, comma, scores the length is last actually should be included, so minus 1. Is that okay? This one is a function, so must have this. Okay, else return what? Return average of 0 to scores the length minus 1. Is that okay?
Yep.
So this one actually is quite a easy problem. I'm missing the S, okay? Here I miss the S. Okay, so I think this is okay. So then we do testing, okay? We do testing. The name I just called it test score. So here we actually need to fit in the scores. So here let's do student records, okay? Integer array S, okay? And then scores equal S, okay? That's what we need to have for constructor. Need to do integer array. Okay, compiles, finish. Test here, okay. So let's do this one, import java.util.star. Okay, in case that you have time to test, try the fastest way to test it, okay? Try one case first, okay? And then here you should do system.out.println arrays.toString, and then working on A, okay? System.out.println, okay? And then here has we need to do this. We need to do student records SR equals new student record with A, okay, and then here we do here with SR that oh, it doesn't allow you to actually put, this is private, okay, this is private, so I changed to public for testing purpose, okay. You should copy it out before you, if you want to test it. Don't actually modify right away. You need to copy it, okay. Copy to a solution region. So here has improved, okay. And system.out.print line, and we want to have SR.final average, okay. So let's see. Yeah, so it is wrong, okay. So now we have this. Let's actually copy this guy over to here, okay. So here I change it to integer array B, okay. And this one change it to 20, 50, 50, 53, 80, okay. 20, 50, 50, 53, 80. And here change to B, okay. This SR, we don't declare it, okay. Okay, we do this, it's fine, SR, okay. And then copy this guy to C, okay. And then copy this whole thing to C, okay. So C will have no 53, okay. And then here we put C, okay. Good. Yeah, okay. So that's actually correct. And then don't forget this value need to be private, okay. Any question up to here?
Nope.
No, let's move on to the next one, okay. I think it has some trouble with this one, okay. Yeah, but actually I'll fix it later using different function name, okay. Let me just do it, okay. Let me just do it. So actually, let me copy this one and put it here. Put a 2, okay, and here let's do as written has improved. Okay, so this one actually just put a 2 there. It should solve a problem since it's actually, let's change it to public, okay. So just make it a interface. So it will actually become okay. So here let's do 2, 2, 2. So then you don't need to modify the program too much, okay. Yeah, I think it's okay. Now let's work on the part 2. Question 2. Question 2. The question involved reasoning about code from marine biology simulation case study. A copy of the code provided as part of the exam. So we have Punch Stacker. Okay, Punch Stacker. So let's see. Punch Stacker. So basically, let me copy the whole Punch Stacker over. Well, it's not allowed, I'm sorry. So let me type it in, okay? So Punch Stacker. Yeah, and then do private environment, the env, okay, and then environment, Okay, environment. Okay, private double mean density. Okay, and then we have actually private integer num under. And then we have public is actually private location random location. Now this question actually is maybe a little bit complicated, okay? Because it involves several classes that's not defined here, okay? So public void at fish, okay? Integer num to add, okay? Okay, these are three functions we need to work on, okay? So A, write a punch stacker method num under. Num under return the smallest number of fish must be added to make the density of the fish in the environment greater the minimum density. If the density of the fish in the environment already greater than mean dish, then the num under return 0. And we call the environment method num row, num column, return the number of rows and columns respectively in the environment. So there is a private method called num under, and you need to write the num under. So return the minimum number of fish that needed to be added to make the population density greater than the minimum density. So here, this class, we have a minimum density. And then we have a environment, the environment called the environment, okay? So the environment actually has number of columns and rows respectively in the environment, okay? And then I think this one probably too old because they already probably in the class, they go over a marine biology simulation case study, okay? So this one is just like the Greek word problem that may depend on some of the information. Here we don't have the environment class, so and no location class that we know, okay? So it's hard for us to guess what's going on. So I'm sorry that I actually include a old problem, but we do not know what it is. So let's assume that here we have an environment, and the environment we has the number of column and number of row, return the number of column and row respectively in the environment. So let's assume that we have a certain number of column, number of row, and then we don't know how many fish we need to add to there, right? So there is a minimum density that's actually is a double value, okay, double value. So that density should be number of fish per square, right? Let's assume that we have rows times column, number of grids, right? And then the average number of fish per square is the minimum is the density, and we need to fit the number of density so that actually you had enough number of the fish we have, right? So we need to have a number of total fish that we have. So let's see here, we have this class, we had the environment, we had number. So we return a new number of fish that need to be added to make the population density greater than the minimum density. And the environment, actually we have the row and column. And then so in the environment, there should be also a number of fish. So here we should have number of fish in this environment. We may also need to have number of columns and number of rows. So let's assume that in the class we have these three numbers. Is that okay?
Yep.
Yeah. So we have these three numbers. So let's assume we have that fish number. Okay, that we have that fish number. So basically, if we want to know about the total, so actually let's do integer total fish needed. Okay, total fish needed should be the integer value based on the number of rows times number of columns. Okay, and these two actually belong to the environment. Okay, as soon that we actually access this, that's the total number of cells in the environment. Is that okay? And then each cell should have a density. So let's do times minimum density. Is that okay? And then after that, your total fish, we should return the so-called total fish needed minus the fish you have. So the environment, that number of fish that existed. Is that okay?
Yep.
Yeah. So that's the number under right now. Your existing fish in the environment and the total fish needed to match the minimum density. The difference is the number of fish that you are under. Okay. Random location, problem to random location. Let's look at random location. Write a file method called random location. Return the random location within the bound of the environment. Random location, you may use the accessible method in the class. Okay, random location. Okay. So here, let's assume that the location has a certain row number and column number. Okay. So here, let's define this one actually because it related to a certain class. So certain case study they had in the old times. So here, let's assume it has a location. Okay. And then you may have integer number of rows, a row number. Okay, you have integer column number. Okay, and then you do have a location, integer R, integer C. Okay, that's your location, and your this that R equals R, this that C equals C. Okay, and then actually we have public to string. Okay, here we should return. Is that okay? So you want this one's location class. So let's assume that we had that location class. Location, let me see. Location, did I spell something wrong? Cannot find the class environment. Okay, we will deal with this number of fish, number of column stuff later. Okay. Minimum density. Okay. Okay, we have a human number we will deal with later when we do testing. Okay. So let's look at this one. We generate a random location for it. Okay, so basically we should have a integer r equals integer. Okay, here we have mass random. Okay, times the environment that number of rows. Is that okay?
Yep.
And then the column sends in, you do random number to generate. Yeah, I know that the information, it may not be enough for you to work on it, but if we want to solve the problem, it should be something like this, okay? And that is because in the old day, they have a fixed case study and fixed AP lab, okay? So now we return new location and then put the R and C over here. Is that okay? That's a random location. You can actually return, okay? Okay, that's the random location. We can generate a random location for it. This number of row and column, we will actually have it. So here, let's do this one. We have this one. We clean this one. And here we have integer number of rows, integer number of columns, integer number of fish. Okay, and we do environment. Okay, integer R, integer C, integer F. Okay, and then number of row equals R. Here we should have a W. Number of columns equals C. Number of fish equals F. Okay, good enough. So we have the number of fish. Number of fish. Wait. Oh, okay. Let's call it this number of fish. Okay, so these two start. Now the last one, we have 8 fish. 8 fish measure number to 8 fish in the environment. You to a random location, then you may use 2D parameter F constructor. So F fish, you may call random location work as a specify. Okay. So this one actually you have the number of to be added, okay? That's then the number of empty location in, okay? Press and random empty slot in the environment, okay? Let me see, actually, I think the environment also need to have a 2D matrix to store the number of the fish. And then actually, we need to add those number of fish to a empty slot. Is that okay? So this one actually, it actually is an add fish function. So we will do the following thing. So we will do for integer I equals 0, I less than none to add Okay, I increase. Okay, so we will do the following. We will do location spot equals random location. Okay, so we will get a spot. Okay, and then we actually will get for each location, we will check in the environment whether it's empty or not, right? So we will actually do what? If empty of the spot that R and spot that column, okay? And in that case, we should put the environment that add fish spot that R and spot C that C, and then add one fish to there. Is that okay?
Yep.
And then otherwise what? Okay, so this one actually we should use a while loop. So actually integer I equals 0, okay? And we do while loop, okay? Because we don't know whether it actually will advance I or not, right? If this one we actually add a fish over there, then other than this, we also do I increase. If we try to add that with one more fish to the cell, and it already has a fish, then we cannot add to there. Then we return. We continue to find. Is that okay? And because the number of the fish to be added is less than the empty location in the environment, so that actually is okay. Is that okay? So now we go back to our environment class. We need to actually check a empty check-in function. So here we should also have integer 2D array m equals new integer and number of rows. Let me see. Not actually this one, no. This one here should be empty. So m is null, actually is fine. Okay, but once we actually been assigned with, that's when we got assigned with a matrix, then we hear our m equals new integer, number of rows, number of columns. Okay, so this fish actually we don't. Yeah, let me see. Actually, let's do number of fish. This one that's assumed is actually 0. Okay, let's see. So don't fit fish in yet. Okay. So this one, let's set the fish to be 0. So here actually this one, the number of fish is from the class. That's not a problem. Okay, that's not a problem. But the constructor, okay, here we don't run the constructor. So we need to do empty spot. Okay, so public boolean, okay, empty R C. Okay, so there is no fish. The next one, we should have a function that actually is called ffish, ffish a certain plus. Okay, ffish. Okay. Here we have empty Boolean integer. Okay. So now we actually have another function called ffish. Okay. Okay. So let's call ffish. Okay, is that okay now? So we pretty much reconstruct the environment class and then ffish, random location, and non-mental. Okay. So this one, because we do not have full information, so if you don't know how to do it, I will actually not going to cost you a point. But that's what happened in 2004. Okay. That's a real problem set actually. So let me see here, environment. Okay. Okay, so then actually we actually need to create a test example. Okay. So now let's create a test example. So let's do test hunt. Okay. So here, let's see, we need to create a environment first. Okay. So the environment in the example here, it say that here it say like 77. Okay. 77. Okay. So it actually is 77. So let's do this one. Test pound. We do in environment E equals new environment. Okay. 77. The constructor is 77. Okay. And there is a fish, number of fish we actually do not include. Okay. So this one is 77. Okay, we create environment. And then pound stacker, we need to put a average and minimum requirement there. So let's do pound stacker. Okay, so we do environment E and then in the double mean. Okay, so these two numbers, and then we say the environment equals E. Okay, the mean equals mean density. That's it. Okay. Okay, we got that, and then come here. We actually create a pound stacker. P equals new pound stacker. And here we actually put in E and 0.5. So let's assume that we need to pass 0.5. Okay. Okay, so now we actually need to do system.out.println. Okay. So we need to actually do 17. So let's do this one. Here, actually, our pound stacker, we will add certain piece. So let's add 17 to there. Okay. So here, let's do pound.add fish 17. Okay. And then here, let's do pound.number under. Okay. Actually is called number under. Oh, okay, that actually is a private method. So let's put it as public now, and for testing, we'll change it back, okay? So here, let's do this one. That's certain fish, and see here we have minimum density, okay? Oh, so here, let me see. Whenever we add a fish, with number of fish into there, we should do number of fish should also plus equals the F, okay? So let's do this one. Let's see, actually, number under, okay. So let's see here. Here we actually get the number of fish, total fish it required is number of column times density. Minimum density required is all. Okay, I'm sorry, I actually messed up. Here should be this one, equal mean value, okay? So let's run again. 7, let's see. 0.5, we have 49. So 49 is 0.5. We have 17. So we actually 24 is okay. So here the number needed so this one the number of this one it actually should be rounded. So it should be rounded here. I press 0.5 and then take that actually it will be rounded. Let me see. I should actually not rounded. I actually should take it to match the seeding function. Okay, because the number of fish should be greater than what it is. So let's do a seeding function. Okay. It's not the button, the flow function should be a seeding function. Yeah, and this one you get A. Is that okay so far? So that one is the ceiling function. Because the density, say, it's 0.5. You need to pass 0.5. You actually not less than 0.5. So you take the flow function that's wrong. It should be ceiling function. Okay? And these two are okay. 18 fish, how many we actually add to there? Okay. So here the pond 18 fish, we got it. And the fish under, we finish it. Okay. So this one, that's actually, this one we can change it back to private. Okay. And what else we need to test? We need to test the location and the fish. So here actually, yeah, now it should be fine so far. Any question up to here?
Nope.
So this one, I think I'll do the same thing over here. I will do this one. I have the under, but I will actually give it a private integer num under 2 for testing, okay? And this one, you will return num under. So I can actually test a private method without changing the type, okay? And this one, change it to public. Okay, so that's the problem we have. I try my best because this one is, we don't have the complete description of the environment class and pond checker class, but this do give you some idea of the pond being a square of 7 pi by 7 cells. And then the density is the number of total fish divided by the number of cells, okay? And then the number of the fish under will be the total number of fish required to meet the minimum density, but it actually should be an integer. So you need to take ceiling function instead of flow function, right? And then that difference between the total needed minus the total you have so far, it is the number of the number under. Is that okay? Okay, that's it for the day. Any question?
Nope.
Yeah, some question that is that require background knowledge won't happen, okay? Won't happen. But here still tells you a way to deal with the random number generator and how to think about if there's a ceiling function or a flow function needed, okay? Okay, if not, then we stop here, okay? Any question?
Nope.
Hi, Emperor, any question?
No.
Farina, any question? How about Albert?
No.
You okay? Okay,
Yeah.
then tomorrow we may have 1 set or 2 set of the problem, okay? Anybody has a test on Friday? Anybody? Has a
This Friday?
Yeah,
Oh.
Friday. Yeah, Friday A push or AP. Friday we have a test. Other than ComSci, do you have any other tests? No? No, then tomorrow we can have 2 sets. Is that okay? Yeah?
Yeah.
Afternoon 1 set and evening 1 set. Is that okay? And I try to give you some review for the concept. Okay? Okay, bye now. Bye now.
Thank you.
Bye-bye.
Thank you.